All right, this video is related to the last quiz that you took, quiz 6. I'm not going to do all 4 problems. The explanations are in Newton, but I kind of wanted to do a couple of the problems to remind you of a couple of anti-differentiation formulas that we learned. So the first antiderivative formula or differentiation formula that we learned was for the reciprocal function. And we did it in class this way. We said, okay, let's look at the derivative of the natural log of the absolute value of x. What is that derivative? Well, to do this derivative, we had to use a piecewise definition of the natural log of the absolute value of x. So we broke it up and we said, okay, we're differentiating when x is negative, we're differentiating the natural log of the the natural log of the opposite of x when x is negative. And when x is positive, we're differentiating the natural log of x. So now in the first one, the derivative of the natural log of negative x, using the chain rule, is going to be 1 over negative x times the derivative of negative x, which is negative 1. So that's for negative x. And then for positive x, it's just 1 over x. And now we look at the two pieces and we see that the first piece, it's just 1 over x, so they're identical, so we can just call it, the derivative is just 1 over x for all x not equal to 0. So the derivative of the natural log of the absolute value of x is 1 over x for all x in the domain. So that means that the antiderivative, or the general antiderivative of the reciprocal function, f of x equals 1 over x, has to be big F of x is equal to the natural log of the absolute value of x plus an arbitrary constant. And that arbitrary constant is necessary. Remember that a general antiderivative is a whole family of functions. They all differ by a constant because they all have the same derivative. All right, so let's use that in the first question on the quiz. So this one says, given that s of x is equal to negative 9 over x plus 9 plus 7 over x minus 2, what is the antiderivative of f of s of x? So this is a sum of two reciprocal functions, or a constant times a reciprocal function. The first one is negative 9 times the reciprocal of x plus 9. The second one is 7 times the reciprocal of x minus 2. So the antiderivative is going to be negative 9 times the natural log of x plus 9 plus some arbitrary constant, which I'll call C1. The second one is 7 times the natural log of the absolute value of x minus 2 plus some other arbitrary constant, C2. I didn't use the same constant for both of these because I don't want to imply that they have to be the same real number. They could be different. So now we can simplify this because some arbitrary real number C1 plus some other arbitrary real number C2 is just some other arbitrary real number. So we can just combine them. And so the final answer should be negative 9 times the natural log of the absolute value of x plus 9 plus 7 times the natural log of the absolute value of x minus 2 plus an arbitrary constant C. And this is required, the C is required to get 100% on this quiz problem because Newton does sometimes say don't include the constant C, but in this problem it didn't say that. And so to get 100%, you had to have that. Now, I am giving a partial credit to the students that left off the plus C in this problem just because they may have been misled by the Newton instructions in other antiderivative problems. All right, let's look at one more question from this quiz. So this is question 4. This one says, what's the antiderivative of h of x equals negative 5 times cosine of x minus 9 plus 5 over x minus 6 minus 5 sine of x plus 2. And this one does say do not include the constant c in your answer. So this is why I think a couple of people may have made that mistake in the first question. They thought that they didn't have to use the constant. So unless it specifically says to leave off the constant, you really do have to have that constant in any general antiderivative. All right, so this question, notice that h of x has 3 terms. It's got a cosine function, a sine function, and a reciprocal function. So the reciprocal function, it's 5 times the reciprocal of x minus 6. So that's going to use the antiderivative formula that we just derived in the previous question, before the previous question. So we're going to use that formula again here. But we're also going to use antiderivative formulas for sine and cosine. Let me remind you of what those are. So the derivative of the sine of x is the cosine of x, right? So that means the antiderivative, or the general antiderivative of the cosine of x, has to be the sine of x plus c. And the other one we got when we differentiated the cosine of x. So derivative of the cosine of x is negative sine of x. So that means that the antiderivative of negative sine of x has to be cosine of x plus c. Now, putting it together, the general antiderivative of h of x is going to be negative 5 sine of x minus 9 plus c1 plus 5 natural log of absolute value of x minus 6 plus c2 plus cosine of x plus 2 plus c3. So each of those antiderivatives has some arbitrary constant. And if I use the same letter c for each one, that would sort of imply that they all get the same constant. And they don't. They don't necessarily get the same constant. So that's why I'm using C1, C2, and C3. However, in our final answer, we don't need 3 arbitrary constants. We can just combine them into one arbitrary real number. So the final answer should be negative 5 sine of x minus 9 plus 5 natural log of absolute value of x minus 6 plus cosine of x plus 2 plus c. We just sort of combined all the arbitrary constants into one real number. However, in this problem, Newton does say leave off that constant. So what you would enter into the Newton box is just negative 5 sine of x minus 9 plus 5 natural log of absolute value of x minus 6 plus cosine of x plus 2. So even though that's technically not the right antiderivative, they told you to leave off the constant, so you had to leave it off to get it correct. All right, I hope this clears up some confusion. Now, remember that if I gave you an extra half a point on the first question, it's not going to show up in the Canvas gradebook because Newton will override that score, and so I have to keep it in my offline gradebook. If you have any questions about your grade, do contact me, and I can tell you what I have. All right, have a great weekend.